finish up a old lesson and then jump into something new. So I didn't get a chance to finish this last time, so just want to jump into this. Hey, how you doing, man? Huh? I made the answer key, but I didn't grade it yet. Yeah. But just from me doing the answer key, I could tell you I thought it was pretty easy. It wasn't that bad. The last couple of questions was bad though, like because there was so many numbers, like you needed a calculator, just to save time. Well, other than that, the rest of it was good. All right, so this is what I want to get into today, right? Chebyshev's theorem. All right. So from our early discussion about standard deviation, we recall that the spread or the dispersion of a set of data about the mean will be small if the standard deviation is small, and it will be large if the standard deviation is large. If we are dealing with a symmetric bell-shaped distribution, then we can make a very definite statement about the proportions of the data that must lie within a certain number of standard deviations. On the other side, on either side of the mean. This will be discussed later in chapter 7 about normal distributions, but let's talk about it. Chebyshev's theorem. For any set of data, either the population or the sample, and for any constant k greater than 1, the proportion of the data must lie within k standard deviations of either side of the mean, and it is at least 1 minus 1 over k squared. Put another way, the sample data with the mean x bar, right? That's our sample mean, and standard deviation s, which is our sample standard deviation, at least 1 minus 1 over k squared, the fractional part of the data must fall in between this range of x bar minus k standard deviations and x bar plus k standard deviations. Blah, 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 right? I have a set of data, right? A whole bunch of numbers. And I want to know what percentage of the data falls in between what two numbers. That's what this is telling you, right? So it's giving you a range that's gonna contain a certain amount of the data from that list of numbers that you get, right? So K is the number of standard deviations, right? So it's how many standard deviations away from the mean that number is. Right? Is it always K? Hmm? It's K is like a general thing. Like K works for any number, right? But let's just make it a little bit simpler, right? All right. I mean, sample mean, yeah. K is a count, is how many standard deviations away you are, you know? But let me make it just a little bit simpler. Think of K as the general formula. That's for like any percentage that I ask you for. Like if I ask you for something like real specific, like 29% of the data or like 42% of the data, right? Then you use the K. But say I ask you something nice like this, right? So let's say for any set of the data, at least 75% of the data falls in the interval between mu minus 2 sigma to mu plus 2 sigma. So whatever the mean is, whatever the standard deviation is, right? If I go two standard deviations to the left and two standard deviations to the right, that middle portion is 75% of your data, right? So on and so forth, right? Say I want 88.9% of the data, right? That's going to be three standard deviations to the left, three standard deviations to the right. Say I want 93.8% of the data, four standard deviations to the left, four standard deviations to the right, so on and so forth, right? Up to 100%, of course, all right? The results of Chebyshev's theorem can be derived by using the theorem and a little arithmetic. For instance, we can create an interval k equal to two standard deviations on either side of the mean. So Chebyshev's theorem tells us that 1 minus 1 over 2 squared is equal to 1 minus 1 over 4, which is equal to 3 over 4 or 75% of the data. So that's how you can use arithmetic to get that. All right. So 75% of the data, right, is the minimum percentage of the data in the interval mu minus 2 sigma to mu plus 2 sigma, right? Notice that Chebyshev's theorem refers to the minimum percentage of the data that must fall within a specified number of standard deviations of the mean. If the distribution is mound shaped, an even greater percentage of data will fall into the specified intervals, right? Called the empirical rule, right? We'll talk about that later. So, what does Chebyshev's theorem tell us? Chebyshev's theorem applies to any distribution. It tells us the minimum percentage of data that fall between the mean and any specified number of standard deviations on either side of the mean. A minimum of 88.9% of the data fall in between the values of 3 standard deviations below the mean and 3 standard deviations above the mean. This implies that the maximum of 11.1% of data fall beyond 3 standard deviations of the mean. Such values might be suspect outliers, particularly for a mound-shaped symmetric distribution. All right. Let's look at an example, shall we? And this will be quick, real quick. Hey, how are you?
Sorry, I'm late, bro. Someone's
No, you're fine.
freaking jacket.
I'm sorry. Did you report it to public safety?
I did, and they told me to leave.
Tell them, like what classroom you're in case they find it, they could just bring it to you. Sorry.
It's a big jacket.
Got you.
Is there like a testing book?
We can do it after. Okay. Yeah. Mhm. I got you. So Chebyshev's theorem, right? Here's an example. Students Who Care is a student volunteer program in which college students donate work time to various community projects, such as planting trees. Professor Gill is the faculty sponsor for this volunteer program. For several years, Dr. Gill has kept a careful record of X equals total number of work hours volunteered by a student in the program each semester. For a random sample of students in the program, the mean number of hours was X bar is equal to 29.1 hours each semester, with a standard deviation of S is equal to 1.7 hours each semester. Find the interval from A to B for the number of hours volunteered into which at least 75% of the data fall into the program where it would fit. So let's take a look at this real quick, right? So I have my X bar right here, which is 29. I have my sample standard deviation right here, which is 1.7. And I want at least 75% of the data, right? And I'm looking for an interval. All right, those are our keywords right there. So let's write it down. X bar is equal to 29.1. Hold on 1 second. Should have highlighted that too, my mistake, right? Our sample standard deviation is equal to 1.7, right? And then you can just go straight into Chebyshev's theorem, right? Even though we know what the answer is, just humor me for a second, right? The formula is 1 minus 1 over k squared, right? I want to solve for k. And I know that I'm looking for what? 75% of my data. Just do a little arithmetic and then you'll solve for k. This is not so bad, right? So this becomes what? 1 minus 1 over k squared is equal to 75 over 100, just like that, right? You know that that 1 is going to become what? 1 over 1 minus 1 over k squared, which is equal to the 75 over 100. And then, in order for me to subtract two fractions, I have to have the same denominator, right? So what would be the LCD here? No. Mhm. What is it? Yeah, the LCD right here. What would the LCD be? K what? No. Mhm. K squared, right? So I gotta have the same denominator. So I'm gonna multiply this by K squared. But what I do to the bottom, I gotta do the top, right? So now what do I have? I have K squared minus 1 over K squared is equal to 75 over 100. Mm, you know what? You know what? I'm looking at this and I don't like doing it this way. I want to show y'all a simpler way. That looked like that was gonna get crazy. Let me show y'all a simpler way. Erase, 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 erase. Listen to me. Whatever. Right? Let's try this again. Let me do something even more simple, right? Put all your numbers on one side and solve for K. Subtract 1 from over here. What do you do to one side? You do to the other. So now I have negative 1 over K squared is equal to 75 over 100 minus 1 over 1. All right? Because that's 1. I'm just moving the 1 to the other side. Yeah. So now LCD 100, you already know what you do to one side, do to the other, and what you do to the bottom, you do to the top. So I get 1 over K squared is equal to 75 minus 100 over 100. What's 75 minus 100? All right. So this is 1 over negative 1 over K squared is equal to negative 25 over 100, right? Right. Now, I have 1 over K squared. I don't like that, right? Simple fix for that. Just flip it. But you know, if you flip it on one side, you gotta flip it to the other side, right? So I'm just turning this upside down. So this is gonna become negative K squared over 1 is equal to negative 100 over 25. Just keep it simple like that, right? I'm gonna divide by negative 1 to get rid of negative 1 here. But you know what I do to one side, I gotta do to the other, right? So now this all becomes positive. K squared is equal to 100 over 25. After that, let's square root both sides, right? This is going to become what? K is equal to 10 over what? What's square root 100 over 25? 5, right? Because remember, when you have the big square root like that, it becomes like this, right? You can do it individually. So you get 10 over 5, right? Help me out. What's 10 divided by 5? What's that? So we have K is equal to 2. That's simple, right? Going back up to the question. I got you. Huh? It's just a little arithmetic to solve for K. After that, look, this is your. I got you. I got you. But look at this real quick. This is our formula. X bar minus K standard. Why is this thing not writing real quick? Hold up 1 second.
Where's that?
It's not on the formula sheet, actually. This one's a little bit easier because it gives you the standard deviation, so you don't have to find it. All right, here we go. So X bar minus K standard deviation minus K times the standard deviation to X bar plus K, the standard deviation. Just plug in the numbers. This is real simple. Just plug in the numbers. 29.1 minus, hey, times 2 times the standard deviation to 29.1 plus 2 times the standard deviation. Little calculator, boom, 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 and you're done. All right. So I'm just going to cheat a little bit. This is 29.1 minus 2 times the 1.7. Hey,
I was
that's
just
going
on
to give me
TV.
nice. What channel?
74. I was making
Mhm.
uh, a
No,
testimony on my organization.
nice. I'm gonna catch a recording. All right, 29.1 plus 2 times 1.7, blah, blah, blah. So I get 32.5. In a nutshell, this is the range that will contain 75% of the data from this data set that was given. That's it. Good. Mhm. Yeah. Say it again.
Like 29.1 F, right?
Is the X bar correct? Yep. Just plug it in. That's it. Yeah. Yeah. Trying to erase all of this stuff. No, it's just something that we got to do. Mhm. That way, when y'all doing y'all major classes, y'all could actually say that y'all heard about this. Yeah, I got you. Hold on 1 second. You said scroll up this way?
Yeah, back to the beginning of it. Oh, no, you can go further.
Oh, down. I'm sorry. Oh, you want to see the K stuff?
Yeah.
Okay.
Go up. Okay, back up. No.
Mhm. Yeah. Well, no, the first thing is actually making that formula 1 minus 1 over K squared equal to whatever percentage is there. Then after that, the percentage numbered over 100, then you subtract the 1 over. Mm. Yeah.
On cross over, you go to the other side.
Right. Yeah. Really?
Yeah.
Yeah. So remember, 1 is a whole number, right? So it becomes just 1 over 1. And then you just get the same denominator, 100, 100, boom, boom. And that's it. Yeah. Yeah, so it's not too bad. Yeah. Yeah. So then after that, now you just subtract 75 minus 100 to get the negative 25 over 100. Yeah. Yeah. So you just find the LCD. Yeah. So that's the 100, the 100 and 100. And then what you do to the bottom, you do to the top. And after that, 75 minus 100 over 100. That gives you the negative 25 over 100. And then flip it, to put the K squared on top to make life easier. Yeah. Whatever you do to one side of the equation, you gotta do to the other side of the equation. So if you're flipping it on one, you flip it on the other, and it's the same thing. Yeah. Yeah. It's, yeah.
Can you scroll further down?
Yeah.
Very good.
Yeah. Sorry. Rewatch the recording and you'll understand it.
Oh, yeah.
Mhm. Whenever I make an announcement, I put the link for the recording in there, so you can just click it. Or you could like, subscribe, and share the video. And then you'll have the whole playlist. Oh man. All right. That's cool. That's cool. Yeah. I mean, it'd be in the description of the video. I'll be telling y'all. Mhm. All right, let's just make a real quick special note about this. So look, averages such as the mean are often referred to in the media. However, an average by itself does not tell much about the way the data are distributed about the mean. Knowledge about the standard deviation or the variance along with the mean gives a much better picture of the data distribution. Chebyshev's theorem tells us that no matter what the data distribution looks like, at least 75% of the data will fall within two standard deviations of the mean. As we will see later on, right? When the distribution is mound shaped and symmetric, about 95% of the data are within two standard deviations of the mean. Data values beyond the two standard deviations from the mean are less common than those closest to the mean. In fact, one indicator that the data values might be an outlier is that of more than 2.5 standard deviations from the mean. All right. That's getting into something else deeper, but we good. Questions on this? Just say no. All right, good. Let's move on.
What did I pronounce it? Chebyshev?
Chebyshev. Yeah. Whoop-de-doo. So happy we're done with that. Absolutely not. Mm-mm. We got two more tests coming up. Yeah. That every test is a midterm. Yeah. And then the final at the end. Hmm.
Any questions?
I forget if it's 9 or 10. It's either 8, 9, or 10. One of those three numbers. Yeah. Woohoo! All right. Let's talk about something useful. So this you might want to write down. This some vocabulary that we about to get into. We'll get back into math, don't worry. So linear equations and inequalities in one variable. Here go your vocabulary, right? You have algebraic statement, equation, inequality, strict inequality, condition statement, solution, ordered pair, solve, linear equation, coefficient, equivalent equations, addition principle, multiplication principle, like terms, coefficient, identity, contradiction, literal equation, right? So when we go home, what words are we Googling? These words. All right. There you go. Or don't write it down. It's being recorded. You'll have the recording afterwards. All right. Your choice. Hmm. I'm not gonna lie. Every time, e- e- every time I look at the videos and I see that and I see one person has viewed it, I always assume it's Jovine. You know, I feel like oh man. You could share it with a friend though.
Yeah.
But you could share it with a friend.
Oh,
Yeah. All right. My fault.
okay, the road.
I mean, it's all in the video, so you could just pause it and cut all the words out. All right. Algebraic statements and solutions, right? So last time we considered algebraic expressions, expressions formed by combining numbers and variables with the operation of addition, subtraction, multiplication, division, exponents, and roots. However, the only thing that we did with them was to evaluate them for given values of the variables involved. As soon as we took one step into the world of algebra, we quickly went back into the world of arithmetic, evaluating expressions by performing operations with the numbers, right? AKA, that's what was our test yesterday, right? So now we'll begin to see some important differences between the world of algebra and that of arithmetic. A mathematical statement is a comparison of two expressions by means of relations of equality denoted by the symbol equals greater than with let me show you that other symbol for greater than. A lot of people get this one confused, the greater than and the less than symbol. I'm gonna show it to y'all. I'm gonna demystify it, give y'all the sauce right now. All right. So this is what greater than looks like. Boom. Right. So this symbol right here, this is greater than. Less than with the symbol that looks like this, right? How I remember that. So back in the day, right? How we used to diss people, we used to go up to them and be like, yo, you a loser with like a L, right? So this L is the same thing as less than. So this is the symbol for less than. The reverse is greater than, right? Yeah. I don't know if that helps, but that's how I remember it. You know. Go ahead.
Greater. I mean, wait, last week, right?
Mhm.
No,
Yeah.
right, is considered correct, so great.
Got you.
I'm sorry, I was on.
I got you. I got you.
It just.
Yeah. I gotta do some research, see if there's a better way to remember it, but that's how I remember it from back in the day, you know? All right. We also have some other symbols here, right? Compound relations, greater than or equal to, denoted by this symbol right here. This is greater than or equal to, and less than or equal to, which looks like this. It's the same symbol, but with a bar underneath, right? This is inclusion exclusion principle. That's what this is, right? They can be broadly categorized as equations, those involving equality, and inequalities are all the rest. The basic inequalities, less than and greater than, are called strict inequalities, while the compound inequalities are the less than or equal to and greater than or equal to. Sometimes they're called non-strict inequalities. The first thing to notice about mathematical statements, unlike mathematical expressions, is that a statement may be true or false. Keep this idea in your head, true or false, right? So, for example, 1 plus 2 is equal to 3. That's a true statement, right? True equals true, right? Now, that's an example of a true equation, while 1 plus 1 equals 5, that's an example of a false statement, right? Because 1 plus 1 does not equal 5, right? All right. Both examples are equations, but one is true and one is false. In arithmetic, whether a statement is true or false can be completely decided by performing all operations, then comparing the resulting numbers. In algebra, however, this is not usually true. An algebraic statement is a mathematical statement involving algebraic expressions. A typical algebraic equation or inequality may be true or false, depending on the values of the variable involved, right? So such a statement is called a conditional statement, right? By contrast, there is no conditional statements in arithmetic. Every statement is simply true or false since there is no unknown quantities, right? This for all the people in the classroom that's trying to study law. All right, just bear with me. All right. Right. Let's look at an example. So for 4.1, this example, consider the algebraic expression x plus 1 is equal to 4. The equation x plus 1 equals 4 is true when the value of x is 3. Right? So if I plug in 3 for x, it becomes a true statement. 3 plus 1 is 4. But the equation x plus 1 equals 4 is false when the value of x is like -2, for example. Right? When it's any other number but the number that makes it equal to is going to be false. All right. These two statements show that the equation x plus 1 equals 4 is a conditional equation, since whether it's true or false depends on the value of the variable x, right? The fact that a typical algebraic statement is conditional prompts the following definition, and we'll come back to this definition over and over again throughout. So, a solution of an algebraic statement, a solution of an algebraic equation or inequality is the value for each of the variables, which, when substituted into the statement, make the statement true, right? Low key, this is how I never get a question wrong in math ever, right? Using this one statement right here. All I do is whatever answer I find, I plug it in and I make sure that it's true. If it's true, I know that the answer is right and I'm done. You know, you just plug it back in. So using this language, we can reformulate the results, right, of the example, right? So 3 is a solution of the equation x plus 1 is equal to 4, but -2 is not a solution of x plus 1 is equal to 4. Let's look at another example, and I cut it off, my fault. Let me remedy that. This is the type of question you're going to see for your homework. All right. Kind of a yes or no deal. Determine whether -2 is a solution of the equation x squared plus 5x plus 6 is equal to 0. How do I determine this? What do you think I'm going to do? Exactly. Just plug it in, right? So what I want to see when I plug in -2 here for x, here's what I want to know. Does this equal 0? Right? I don't know. Let's see. -2 squared, what's that? Yeah, what's that? 4, right?
Oh.
All right, help me out. What is 5 times -2? -10 plus 6. I'm not sure, but I want to know, does this equal 0? Right? All right, 4 minus 10 is what? What's 4 minus 10? -6. So -6 plus 6. I'm still not sure, but does that equal 0? And in fact, -6 plus 6 is 0, right? So 0 equals 0. This is how I check my answers, right? Step by step.
Oh, because
Mhm.
loss of thumbs and then these thumbs.
Yeah. So now you break even at 0. Yeah. Mhm. All right. I'm giving y'all the good sauce today, right here. This is how you check your answers. So getting a question wrong in math class is actually a choice. You don't have to. You can just do this and prove it. You know?
Professionally.
Yeah.
Don't do that.
That's true.
Don't do that.
It's true. It's true.
So for any problem, you could just like plug it in.
You just plug it in. Yeah. That's how I be cheating on my classes. I just plug it in and just verify. You know?
So how would you do it? Like, let's say with like a connection or like a problem like that.
Just plug it in. Just plug it in. Oh, my fault. I was gonna give y'all another example. All right? Y'all have this for homework though. All right? It gets more complicated than that. And when you get deeper into math, you're doing all this work to find an answer. This is just simply plugging it in to verify that the answer that you found was the answer. You know? Yeah. Mm. Just being able to plug it in. That's it. Yeah. You're welcome. All right, you guys try one. Oh, my fault. I didn't even answer the question above. The answer was yes. Sorry about that. All right, try this one. Determine whether -3 is a solution to this equation. I didn't even do it yet, so. Mm-hmm. -18 you got? So that's not zero. So it sounds like the answer is no. All right, false. All right, I'll take that too. Yeah.
It's not supposed to be.
No, no, no. I take false. I'll take false. Yeah. You want to get the lawyer example? I got you. I got you. I'll take that. You can do that. Yeah, yeah, yeah. You can say true. You can say true or false, yes or no. Same thing. Yeah. Yeah, yeah, yeah. That's that lawyer answer. That's why I got you. So what I want to know, does this equal zero? You said 18, right? So let me see. I got nine. It is zero? That's 15 plus six. Not even sure. This is -6 plus six.
You, this is about the computers. Like small teachers.
Yeah.
Yes.
All right.
The -3 plus six
Mhm.
plus five, then the answer, then -3.
Mhm.
Yeah,
Yeah.
exactly.
So anytime you guys got a letter, a variable, you put it in parentheses, the number, and just do the math. Boom, 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 and that's it. Right? Or type it in the same way that it's written there.
Now I got step because something got different.
Got you, got you. I mean, I ain't even get that myself, so we in the same boat. Mhm.
I think you can have this,
You messed it up.
yeah, I didn't get, what you got, what you got?
With no parentheses, I got 18. But I forgot with a start with later, so with a letter to numbers, we have to put parentheses.
No.
Sorry, I'm gonna let you get the next one right. The next one's even easier than this. Yeah. So here we go right here. First, I got to talk about it though before we try it, right? So notice that in the previous two examples, we found two different solutions to the same equation. In the case of statements with more than one variable, we need to specify a value for each variable in order to specify a solution. Many times we will encounter equations or inequalities in two variables, x and y. So here's the convention. When specifying a solution of an equation or inequality in two variables, x and y, we will use ordered pair notation. So an ordered pair is a pair of two numbers grouped with parentheses. So for example, a typical ordered pair might be like 4 comma 7, just making it up, right? In this case, the first number will always represent a value for x, while the second number will always represent a value for y, right? A full treatment of two variable statements is found in the next chapter, whatever. However, we can already get a feeling for them in the context of deciding whether a given ordered pair is a solution or not. So let's try this out. Tell me if this ordered pair, 1 comma -2, is a solution to this equation right here, 3x plus 4y equals 11. Mhm. So what you gonna do? How you gonna do this? This your question. It's easy. It's only 1 and 2. Oh, you want Sarah to do it? All right, go ahead, Sarah. Good. Which one is the x value? Good, right? This is x and this is y. Very good. So that's all I'm gonna do. I'm just gonna plug it in. So let's see. 3 times 1 plus 4 times -2. What do I want to know? Does that equal 11? I don't know. Right? Let's do the math. What's 3 times 1? I heard somebody say 1. Yo, y'all funny. Y'all funny. What's 4 times -2? Right? Mm-hmm. No, -8, right? Now here's what I want to know. Does that equal 11, right? So what's 3 minus 8? -5, right? So -5 does not equal 11, right? So this is not a solution. Or
So that would be like the final.
you could say false. Yeah. Anyone, right? And this is how you get A's in every single question. Mhm. Or get it wrong if you want to. Some people do that. I don't know. Let me just do one more, then I'll call it a day with y'all. We'll finish this next week. Just one last one. Because I feel like this one looks a little fun. All right. Feel like I'm gonna ask y'all this one again too next week. All right. But for right now, it says determine whether 5 comma -1 is a solution to the equation 3x plus 4y is equal to 11. All right. Let me rewrite that real quick. So I have 3x plus 4y is equal to 11. That's the way it looks, right? And I want to know if 5 comma -1 is a solution to that. How do I do this? Huh? It is? Okay. So somebody tell me how to do this. Good, good, good. Times -1. And I want to know, does this equal 11? So 15 minus 4, does that equal 11? And then 11 equals 11. It's a true statement. Yes, it is.
Wait, what did you just do? Why do?
Mhm. What did I do? You tell me. You tell me why. What's next to the 4?
Oh.
Mhm.
Okay.
All right. So that's that. I'm gonna call it. Any last minute questions? You good? All right. I can take this down. Thank you.